Okay, so this is a key to Worksheet section 2.4 part 1, and that's the one dealing with 3 sets of Venn diagrams. So notice it looks something like this, at least for number 2. But in number 1, you're given that the universal set consists of the natural numbers from 1 through 10, and set A has these 4 elements, set B has these 4 elements, and set C has these 4 elements. All right, in part A, you want to find A union and then B intersects C. Notice that B intersects C is in parentheses, so we're going to do that first. Always do what's inside the parentheses first. All right, so let's go ahead for 1A. For 1A, let's go ahead and find what B intersects C is. All right, well, I'm going to go ahead and just write out what B is. So B is this set, 2, 4, 6, 8. And then I'm going to intersect that with set C, which consists of the elements 3, 4, 5, 6. All right, so the intersection is what do they have in common? So what do these two sets, B and C, have in common? Well, they have the elements, let's see, 4 and 6. All right, so 4 and 6. All right, so that's B intersects C. Now let's go and actually look at this again now. All right, so let's look at A union, and then remember we had B intersects C. All right, so I know what this is now. So this is the set for 6, and I'm going to union that with set A, and set A has the elements 1, 2, 3, and 4. And so basically the union is you just list all the elements that you see. And I only list it once. So I see 1, 2, 3, 4. 4 is already listed, and 6. All right, so that will be the answer to number 1A. So it will be 1, 2, 3, 4, and 6. Okay, number 1B. All right, so 1B, so you have A union B intersect A union C. All right, so let's go ahead and look at A union B first. I'm going to go ahead and do that right here, A union B. All right, so A union B, so I know that A is a set 1, 2, 3, 4, and I know that B is a set 2, 4, 6, 8. Okay, and so the union then would be every element you see. So 1, 2, 3, 4, 6, and 8. Okay, so that's going to go here. So A union B is this. All right, so notice I'm doing it step by step. So that's 1, 2, 3, 4, 6, 8. I'm going to intersect that with A union C. So let's talk about A union C. All right, so A union C, then, again, A is this set, 1, 2, 3, 4, union, and then C, remember, is 3, 4, 5, 6. So the union then would be every element you see. So 1, 2, 3, 4, 5, 6. So that goes here. 1, 2, 3, 4, 5, 6. And so therefore the intersection here would be what do they have in common? So they have 1, 2, 3, 4, and 6. That's about it. All right. So that will be the answer to that one. So 1, 2, 3, 4, and 6. Okay. C. So C, you want to find A intersect B complement union C. All right, so A intersect B complement union C. So again, we're going to do what's inside the parentheses first. So I need to find what B complement union C is. Before I can find B complement, I need to look at what B is. So to find B complement, let's look at B. So first of all, remember the universal set is 1, 2, 3, all the way to 10, right? Okay, so I'm going to go ahead and list it all. All right, and then B, remember B is the set that is 2, 4, 6, 8. And so B complement then would be every element that's in the universal set that's not in B. So I'm going to take 2 out, I'm going to take 4 out, I'm going to take 6 out, I'm going to take 8 out. So B complement then would be the set 1, 3, 5, 7, 9, and 10. Okay, so that's going to go here. So that's going to be 1, 3, 5, 7, 9, and 10. Union, I'm going to union that with set C, and set C is just 3, 4, 5, 6. And so therefore, B complement union C then would be every element you see. 1, 3, I see a 4, 5, 6, 7, 9, and 10. So that's this right here. So A then, remember, is 1, 2, 3, 4, intersect this set here, which is 1, 3, 4, 5, 6, 7, 9, and 10. And so therefore the intersection then would be, let's see, there's 1, 3, and 4. So that's it, 1, 3, and 4. So that's going to go here. So 1, 3, and 4. Okay, and then letter D. So letter D then says this. I'll go ahead and do that here. So letter D is B, said B intersect A complement intersect C complement. Oops, that's parentheses right here. All right, so let's find what's inside the parentheses first. I'm going to find A complement intersect C complement. So again, before I can find A complement, I need to look at what A and the universal set is. Remember, the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is the set 1, 2, 3, 4. So therefore, a complement would be every element that's in the universal set that's not in A. So I'm going to take 1 out, 2 out, 3 out, 4 out. So a complement then would be 5, 6, 7, 8, 9, 10. Okay? Now so that's this right here. So let's find C complement now. So C complement, so again, the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And C is the set, let's see, 3, 4, 5, 6. 3, 4, 5, 6. So C complement then, I'm going to take 3 out, 4 out, 5 out, 6 out. So C complement then would be 1, 2, 7, 8, 9, 10. All right, so now I know A complement. So A complement is this. 5, 6, 7, 8, 9, 10. I'm going to intersect that with C complement, which is this. So I'm running out of room. Let me go ahead and do that here. 1, that's 1, 2, 7, 8, 9, 10. And so what do these two sets have in common? So that's going to be, let's see, 5, nope, 6, no, 7, yes, 8, yes, 9, yes, and 10, yes. Okay? Now what you found, see, all of this work was just for this part here. So that is 7, 8, 9, 10. All right, now B is just a set that is 2, 4, 6, 8. And so you want to intersect those two sets, and so it looks like the only thing they have in common, the only element they have in common is the set with the element 8. So that's just going to be 8 right here. Okay? All right, so that was number 1. All right, let's look at number 2. All right, so number 2, you want to construct this Venn diagram. So you have the universal set and sets A, B, and C. All right, so you want to fill this Venn diagram in with this information. All right, so universal set consists of only these letters right here. Set A consists of these elements, set B and set C. Okay? All right, remember the way you want to complete this Venn diagram is to look at the innermost one right here first. This one right here. So remember, this right here means this right here is what elements do set A, B, and C, all those three, have in common. So set A, B, and C. So you're going to fill this in right here first. All right, so this right here is this. So you're looking at A intersect B intersect C. Okay? So if we look at A, B, and C, what do they have in common? Let's see. They have, okay, they don't have A in common. I'm just looking at D compared with the others. So you just got to look at one of them compared with the others. D, nope. E, yes. So there's an E in common. What else? G, no. H, yes. I, no. And then J, no. All right, so that's the only two letters that those three sets have in common. So I'm going to put an E and H in here. Okay? All right, so then you work within this first, and then you go these three next. All right, does not matter which one you look at next. So let's look at this one. All right, now be careful, because this, so remember, if you just look at this little piece right here, that little piece right here, so remember that piece right here indicates what do, this right here, okay, what do A and B have in common, okay? But remember, this is E and H here are the elements that all three have in common. So let's look at this. So in looking at this, what I would do is I would ask myself, what's A intersect B, okay? What's A intersect B, but not including C, but not including C, okay? So you don't want C in here, you just want A and B. All right, so let's look at A and B. So A and B, I'm looking at it. They don't have A in common. They don't have D in common. They have E in common. Yes, they do. But here's the problem. I already have it listed. So don't put it here, because E must go here. Okay. All right. If you put E here, then you're saying that E is not part of C, and E is part of C. So you got to think like that. All right. Let's go to G. So G they have in common. I don't have it listed, so I'm going to list it here. So it'll be G. So put G here. H, I already have it listed. I, no, and J, no. So that's the only thing. So G is the only element that goes in here. All right, so you do the same idea with this one. So this right here would be the idea of B intersects C, but not A. Okay. So what that means is this, I'm going to look at B and C. What do B and C have in common? Let's start with B. Do they have B in common? Nope. Do they have E in common? Yes, but I have it listed. So don't list it here. If you list it here, you're indicating it's not part of A, and it is part of A, because it's here. All right, G, no. H, yes. I already have it listed though. L, no. So that's going to be nothing. You're not going to put anything there. Okay, so leave that alone. All right, let's go to this one. So this right here, you're going to fill that part out by asking yourself, what is A intersect C, but not including B. All right, so let's look at A and C. So they have A in common, yes? You see A and A and C. All right, I don't have it listed anywhere, so I'm put A here. Let's look at D. Do they have that in common? No. They have E in common, but I have it listed. It's already here. G, no. H, yes, but I already have it listed. I, no. J, no. So that's it. That's all you put there. Okay, so that's just going to be A. Okay? All right, now we work on the outside. So the rest of this is easy. Okay, so the rest of this, for instance, we look at A. So you want to put all of A in here now. So look at A. All right. A has the element A. Do I have it listed in A? Yes, I have it listed here. Do I have D listed? Nope. So I'm going to put D here. Do I have E listed? Yes. Do I have G listed? Yes. Do I have H listed? Yes. See, that's all part of A. Do I have I listed? No. So I'm going to list I. Do I have J listed? Nope. So I'm going to list J. Okay? All right, let's go to B. All right, B consists of the element lower letter B. Do I have it listed? Nope. So I'm going to put it. Do I have E listed? Yes. E is in B. It's right here. G, I already have it listed. H, I already have it listed. L, I don't. Okay. Let's go to C. All right. A, I already have it listed. That's in C. Is letter C in C? Nope. So I'm going to put it. Is letter E in C? Yes. Is letter H in C? Yes. Okay. And then what you got to do is fill in any element on the outside. All right, so that's where you go to the universal set. So do I have A listed? Yes. Do I have B listed? Yep. Do I have C listed? Yes. Do I have D listed? Yes. Do I have E listed? Yes. Do I have F listed? Nope. So I'm going to put F here. Do I have G listed? Yes. Do I have H listed? Yes. Do I have I listed? Yes. J? Yes. K? No. In fact, you know it goes here because is K listed anywhere in here? No. F is, you don't see F anywhere in here, so it's going to be on the outside. You don't see K anywhere in here in A, B, and C, so you list on the outside, and then L, I already have it listed. Okay, so that's how you construct a Venn diagram. All right, so that's going to take care of section 2.4, part 1.